Hello and welcome to today's lecture on multiplexer applications. In the last lecture, we have discussed the various techniques of multiplexing, a set of techniques that is used for multiplexing like frequency division multiplexing, time division multiplexing and wavelength division multiplexing, which is a variation of frequency division multiplexing. And also you have discussed two different types of time division multiplexing, that is your synchronous time division multiplexing and asynchronous time division multiplexing. These multiplexing techniques have numerous applications. In this lecture, we have chosen two applications which are very common and widely used in our day to day life. Let us see the outline of today's lecture. First, we shall consider the telephone system which you are using in our daily life, and in our telephone system you will see there are two types of services: analog services which were prevalent, which were in use for a long time. Now, with the advancement of technology, now the digital services are also available, which I shall discuss in detail. Then another very important technology which is becoming very useful for broadband data transmission, that is your DSL technology, digital subscriber line technology. And this DSL technology has four variations: ADSL, SDSL, HDSL and VDSL. We shall discuss about them in detail. And on completion, the student will be able to explain the operation of telephone system, how a telephone system works, he will be able to tell. Then explain different types of services provided by the telephone system. It will make him aware of the different types of services that is being offered by the telephone system, and he can choose the service required for his application or her application. Then we shall discuss about the DSL technology, and we shall explain, he will be able to explain how the local loop is being used to provide broadband service by using DSL technology. He will be able to explain different types of DSL technologies as I mentioned. So, let us have a look at the telephone system. As I mentioned, one of the many applications of multiplexing is the telephone network, which makes use of both FDM and TDM. So, here it is a combination of frequency division multiplexing and time division multiplexing that is being used in our telephone system. So, it is a very interesting application. So, this is the block, the telephone network. As you can see, to the telephone network a number of telephone sets are connected, which we call handsets. Handsets are connected. Obviously, these handsets represent telephones in houses, in offices, in universities, in all the places. These telephones are now distributed in all places, and this telephone network is now a global network. It is no longer a small telephone network. Now, it is a global network. From anywhere you can call to any other place, and by dialing a number. So, let us have an inner look of the telephone system or telephone network. Telephone network, as you can see, has got these distinct components. First, local loop. This local loop is connected to the user. Through this local loop, the user is connected. Here you have got your handset, and your handset is connected to the local loop. This local loop is essentially a analog line which has bandwidth of only 4000 hertz, and that is adequate for voice communication. So, it is simply twisted pair of wire, which is led from the end office, which is essentially the telephone exchange. From the end office, with the help of twisted pairs of wire, it is connected to our home or office, and it provides you a analog transmission capability with bandwidth of 4000 hertz. Then these end offices are connected, as you can see, these end offices are connected using trunk lines to tandem offices, and these tandem offices are in turn connected through trunk lines to regional offices. So, this is a some kind of generic representation of the telephone network. So, here I have shown only few trunk lines. It can be through a cascade of trunk lines, and obviously these trunk lines are implemented with the help of high speed lines. For example, these trunk lines can be implemented by using coaxial cable. It can be implemented by using microwave link. It can be implemented by using optical fiber. It can be also implemented by satellite network. So, you may be asking why these are implemented not by using twisted pair of wire. The reason is, here these trunk lines are of much higher bandwidth. The voice lines which are only of 4 kilohertz bandwidth, but a number of such lines, such channels are combined with the help of multiplexing technique to have much higher data rates, and these are connected using trunk line. That is why you will require coaxial cable if the distance is not large, or you have to use microwave link or optical fiber and satellite network. So, at different links it can be it can use either microwave link or optical fiber or satellite link. So, it is not uniform. This link can be, this particular link can be microwave link, this can be a satellite link, this can be a optical fiber link, and so on. So, in the path, as the one user, this user 1 is connected to user 2, it can go through a number of paths through the trunk lines, and that can be a combination of various types of transmission media, as we have already discussed. So, this gives an overview of the telephone network. Now, let us see what are the types of services the telephone network provides to us. The services can be broadly divided into two types: analog services and digital services. Analog services are available from the telephone companies for a long time. That means, these analog services we are using for quite some time, and with the advancement of technology, digital services have been introduced, and in recent times, and nowadays we are able to use the digital services. So, I shall discuss both analog services and digital services one after the other. First, let us focus on the analog services. The analog services has got two different types of services. One is known as analog switch service and another is analog lease service. Analog switch service is the most commonly used service that we use at home. We get a telephone connection from the telephone exchange, that is your local office, using local loop, which is nothing but a twisted pair of wire, and we get the telephone service at our home, and that is the analog switch service, that is the most commonly used service. And analog lease service is one that provides a dedicated line between two users. Let us see the difference between the two. The first one, the analog switch service, in this particular case, as I mentioned, the subscriber's handset is connected to the telephone network by twisted pair cable, which is known as local loop, via an exchange. So, to the exchange, through that exchange our handset is connected through the local loop, and the signal on the local loop is analog in nature, having bandwidth of 0 to 4000 hertz, as I have mentioned. Now, there is a switch in the exchange that connects the subscriber connects a subscriber to the subscriber of the dial number for the duration of call. You look at this term. Here you have got the so here, as you can see here, we are having a only for the duration call, duration of call we are getting the service, and for other times it is not connected, and the network, that is why is referred to as public switch telephone network. Why? That will be clear from this diagram. Here you see we have got a handset at home, there is another handset in a neighboring home that is connected through a telephone network. In the simplest case, it can be the local exchange, and these two the telephones can be connected to the local exchange and using two local loops. These are twisted pair of wire. Now, only when the number is dialed from here, this user 1 at home, this user 1 dials a number, this switch establishes a connection from here to here. So, a connection is established from here to there, and the home at the other end gets the dial tone, and only when it is picked up a link is established, and only for the duration of call the link is established, and when the call is terminated, that means after the communication is over, then the handset is put down at both ends and the link is disconnected. So, that is why I mentioned that only this link is only for the duration of call, it is not connected otherwise, and that is why the network is referred to as public switch telephone network. So, it is doing some kind of switching, and only for the duration of call it is establishing a link between two users through the telephone network. Now, it can be through a single exchange or through those trunk lines and involving more offices, as I have mentioned earlier. Now, let us consider the other types of service, analog lease service. There are many applications in which an user wants to send data continuously or wants to communicate continuously. In such a case, analog lease service is available, and in this case the important point is, although the connection is through an exchange and there is a switch here, but the switch has established a permanent path, as you can see, between these two handsets. So, the user 1 need not really dial a number to establish a connection to user B. Already a link is established. So, whenever he wants, he simply can talk or send data through this leased line. That means, whenever the usage rate is very high, people are talking all the time or people are sending data all the time, in such case this kind of lease line can be established. So, it is dedicated, and that means this the whole bandwidth is available all the time, it is not switched one, and this is in use in many situations where the usage rate is much higher. Now, as I mentioned, the various links can be of higher bandwidth, and in such a case, for better utilization of the infrastructure, analog signals are multiplexed to provide lines of higher bandwidth. So, you have to combine several signals or several low bandwidth channels to form a high bandwidth channel which can be sent through transmission media of higher bandwidth, and the frequency division multiplexing is used to combine many lines into fewer lines in a hierarchical manner. So, a hierarchical in a hierarchical manner, this combination is done, and there are variety of hierarchy available nowadays. The hierarchical system used by AT&T companies is shown here, and as we shall see in the hierarchy, it is divided into groups, super groups, master groups and jumbo groups, as it is shown in this diagram. Here, as you can see, 12 voice channels are combined by using frequency division multiplexing technology to form a group, and this groups here it can be sent through a single telephone line. Single line need not be a twisted pair, it can be some other transmission media. Here, as you can see, the bandwidth is 48 kilohertz, and again 5 such groups can be combined to form a super group, where each super group will have bandwidth of 240 kilohertz, and as you can see, using this bandwidth you can send 60 voice channels. In the previous case, you are having 12 voice channels, and then 5 such groups are combined to form a super group, and this line, through this line you can transmit 240 kilohertz bandwidth, and so it allows you to send 60 voice channels. That means, suppose there are 2 exchanges and 2 exchanges are connected, and it is necessary to provide to establish link of 60 voice channels, then a single transmission media can be set up between 2 exchanges, and through which 60 voice channels can be sent. Then these super groups can be combined to form master groups, and as you can see, each master group line can carry 600 voice channels having bandwidth 2.52 kilohertz, and again 6 master groups can be combined to form a jumbo group, and this jumbo group has bandwidth of 16.984 kilohertz, which can carry as many as 3600 voice channels. So, as you can see, a transmission media, if it is a twisted pair, it can carry 4 kilohertz. A transmission media of higher bandwidth, a single line can be used to carry 48 kilohertz or 240 kilohertz or 2.52 kilohertz or 16.98 kilohertz, providing you and voice channels of different numbers starting from 12 to 3600 voice channels. So, it will lead to better utilization of the lines of higher bandwidth. Now, let us look at the digital services. As I mentioned, because of the advancement of technology, now the digital services are becoming increasingly popular because of higher immunity to noise and other interferences. If you send in terms of zeros and 1, it is very unlikely that it will get corrupted. On the other hand, the analog signals get corrupted with noise, and if you are sending digital signals at the other end with the help of repeaters, it can be, the noise can be separated and you can get back the original zeros and 1s. And also another important aspect is the digital transmission provides you lower cost compared to the analog transmission, because digital processing has become cheaper. And there are 3 categories of digital services. First one is switched 56, second one is DDS, third one is DS. I shall explain each of them one after the other. The switch 56 service, which is nothing but a digital version of the analog switch line. I have already explained that analog switch line. So, it is essentially the digital version, and it allows you data rate of up to 56 kilobits per second. And of course, since it is digital in nature, there is no need to have modem in this particular switched 56 service. However, there will be a need for another device known as digital service unit or DSU, and this DSU provides you better speed, less susceptibility to noise and better quality. And this particular service provides you bandwidth on demand. You may recall that when I discussed about that inverse multiplexing, there a a high speed line can be divided into a number of low speed lines to provide service based on bandwidth on demand. For example, whenever we are sending voice signal, then the bandwidth requirement of 56 kilobits per second may be sufficient. Whenever we are sending data, the bandwidth requirement can be double of that. In such a case, 2 lines can be demanded. Whenever we are sending video, say 1.544 megabits, then 24 or more number of this switch 56 lines can be provided. So, this switch 56 service allows you to have bandwidth on demand by using that inverse multiplexing. So, using this service you can have inverse multiplexing, and here that switch 56 service is shown. It is same except that instead of modem you have got that DSU, digital service unit, at both ends, and it is connected through a switch at the telephone exchange. So, whenever the dialing is done, this is also a dialed connection. So, dial up line through this, whenever the dialing is done, link is established between these two DSUs, and the communication is possible between two users connected through the telephone exchange. Then comes the digital data service or DDS. So, this is again the digital version of analog lease line. We have already discussed the analog lease line. So, here also you can have leased connection or dedicated connection, and it allows you data rate of up to 56 kilobits per second. However, there is a choice. Since it is dedicated, you may not be always using 56 kilobits per second. So, in such a case you can choose data rates of 2.4 kilobits per second or 4.8 kilobits per second or 9.6 kilobits per second or 19.2 kilobits per second or 56 kilobits per second. That means, whenever you are using this DTS service, depending on your requirement, you can specify what is the bandwidth you want. It can vary from 2.4 kilobits per second to 56 kilobits per second. So, since it is available all the time, you can make use of the bandwidth by sending data, by scheduling the data all the time. However, as your need grows, you can keep on increasing from 2.4 kilobits per second to 56 kilobits per second. Of course, here also there is a need for that digital service unit. You do not require a modem, but you will require a digital service unit. However, in this case that DDS that is being used is cheaper and simpler. Why? Because you do not require a keypad. In the previous case, where it was switch 56 service, there was a need for a keypad, so that a number can be dialed. You can keep the press the keys so that a number can be dialed, but here it is lease service. So, already a permanent link is there. There is no need for dialing a number. So, the DSU is simpler and cheaper because it does not require a keypad. So, here is the schematic diagram for digital data service DDS, and as you can see here, you have got two DSUs connected, permanently connected through the telephone exchange. Of course, there is a switch here, that switch I have not shown. So, that switch is establishing connection from this to this, and this is permanent one, and the data rate can vary from 2.4, as I have mentioned, 2.4 to 56 kilobit per second through this line. So, this is the digital data service. Finally, you have got the digital signal service, and this digital signal service DS service provides you a hierarchy of digital services. Here the bandwidth requirement can be as small as 64 kilobits per second, and as your need grows it can go up to 274.176 megabit per second. So, the hierarchy is available through a number of services, and these services are known as, for example, DS0. DS0 service is similar to DDS. It is a single digital channel. However, the bandwidth is here 64 kilobits per second, that data rate that is being allowed instead of 56 kilobits per second. And DS1 is provides you 1.544 megabits per second service. How I shall explain? Then DS2 provides you 6.312 megabits per second service. DS3 allows you 44.376 megabits per second service. So, through a single transmission media you can have this data rate 44.376, or you can have 274.176 megabit per second service if you are having a DS4 service. And these services are implemented with the help of T lines. So, implementation is done by using T lines, and for example, as I shall show you how it is being done. Say DS, this is the DS0 service, each of 64 kilobits per second, and then 24 such channels are combined by using frequency division multiplexing to get DS1 service, and here the bandwidth is 1.544 megabits per second, where the 24 DS0 channels are accommodated, and by combining 5 such lines you can have 6.312 megabits per second, or sorry, not 4, not 5, 4 such lines, and you can have 4 DS1 or 96 DS0. You have a choice through each of these lines, DS2 services. Then a DS3 service provides you 44.376 megabits per second, where you can have 7 DS2 or 28 DS1 or 672 DS0 channels. And finally, you can have DS4 service, which will provide you 274.176 megabits per second, and in either you can have 6 DS3 or 42 DS2 or equivalent number of DS0 services. So, as you can see here, increasingly you can have services of increasingly higher bandwidth, and these are supported with the help of those T lines. For example, those T0 T lines, and I shall show you how a T1 line can be used. T0 is 64 kilobits per second. How a T1 line can be used for analog transmission using PCM for conversion to digital signal. How you are getting 1.544, that is being shown here. Here, as you can see, 24 voice channels are combined to combined to form one T1 line, and as you can see, each voice channel of 4 kilohertz is converted to 64 kilobits per second using pulse code modulation technology. That means, we are sampling since it is 4 kilohertz bandwidth, you have to sample at the rate of 8 kilohertz, then by using 8-bit quantization, that means an analog to digital conversion by using 8-bit AD converters, you can have 8 kilohertz into 8, that means 64 bits per second each channel. Then these 64 kilobit per second channels are combined by using a time division multiplexing. Here, as you can see, you are not using frequency division multiplexing, because here the this is digital transmission, it is no longer analog. In the earlier case, for analog services it was frequency division multiplexing. Now, as you can see, it is time division multiplexing. So, the time division multiplexing is giving you combining those 24 voice channels, and as you can see, you have 24 6 kilobits per second voice channels, and it has got 8 kilobits per channel overhead, and this overhead is essentially for the purpose of synchronization. Synchronization bits are there, as it is shown in this diagram. So, here as you can see, this is a frame where channel 1, channel 2, from each channel 8 bits are taken, 8 bit from channel 1, 8 bits from another second channel, and this way 24 channels are there, and for each frame there is a synchronization bit of 1 bit, and this frame therefore comprises 24 into 8 plus 1, 193 bits, and you have got a total of 8000 frames. So, T1 line supports you 8000 frames of each of 193 bits per second, giving you 1.544 megabits per second. That is how you get T1 frame of 1.544 bits per second. Now, this has opened up a new option. Earlier, suppose a particular house or a business organization requiring 24 telephone lines, then from the telephone exchange it was necessary to connect by using 24 different twisted pairs of wire. So, 24 pairs of wire were coming from the telephone exchange to the business house. Now, it is no longer necessary. You simply take one T1 line, and in the business house you have a small that PCM exchange, you can say, and from there you can get back the PCM lines. So, there is no need to take 24 pairs of wires. Instead, just one cable, one transmission media, it can be, depending on the length, it can be either twisted pair or some other transmission media, and then here by that conversion is done from TDM, that there will be a small exchange, PCM exchange, which will convert to give you 24 voice channels. So, small telephone exchange can be set up in your home or in a complex, in a residential complex or in a business house to give you 24 separate voice channels or 24 different telephone sets. Now, there is another possibility. For example, can these T1 lines be shared? A small business organization may not require the full T1 service or T1 line bandwidth, that means 1.544 megabits may not be required. Can it be shared? That is possible with the help of this DSU CSU unit. This is customer service unit service. What can be done? Here, for example, say 4 subscriber wants to share a T1 line. That can be done. Say in a building there are 4 business houses, and each of them having requirement of 1/4 of bandwidth of the T1 line. Then these 4 subscribers can share a single T1 line with the help of a DSU CSU unit, and from each of these business house it is connected to the DSU CSU. Say here it is 1/4 of T1, 1/4 of T1, 1/4 of T1, there will be another one, and they are combined, and this goes to the telephone, that is your telephone company, and you get some kind of shared T1 service. So, this kind of flexibility is being offered by these T1 lines. Now, let us switch to another important technology, that is your digital subscriber line, DSL technology. This DSL provides you a much higher bandwidth, broadband. How? And that is being done by using the local loop. Earlier we were having only 4 kilobits per second bandwidth through the local loop, but although the twisted pair of wire has the capability of transmission of much higher bandwidth, that is 1.1 megabits per second, we are restricting it because of our requirement. We were filtering putting low pass filters, so that only 4 kilohertz signals go, but now it can be that filter can be removed. So, inherent bandwidth of 1.1 megahertz of the wires that is being used in existing local loop can be exploited or has been exploited in DSL technology. Of course, for that purpose it has to use suitable modulation techniques as well as multiplexing techniques. So, here you will see it has used a combination of modulation and multiplexing techniques to achieve this high bandwidth using local loops. And DSL again has got several versions: ADSL, VDSL, HDSL and SDSL. So, these family can be represented by XDSL. So, X can be A, V, H or S, any one of them. Let us see these 4 different versions one after the other. ADSL stands for asymmetrical DSL, digital service line, and this has been primarily designed for residential users. And of course, as we shall see, although it will be able to provide much higher bandwidth, but based on the condition of the local loop, the data rate is selected in adaptive manner, because the local loop wire is twisted pair. That twisted pair of wire can run for a kilometer or 2 kilometer. So, its length can be different, the quality of cable can be different, the cable can pass through different areas where the noise levels can be different. So, based on that the data rate is selected in adaptive manner, and it uses a novel modulation technique known as discrete multitone technique, DMT, which I shall explain in detail, which uses a combination of QAM, quadrature amplitude modulation, and frequency division multiplexing. And as we shall see, the available bandwidth is 1.104 megahertz, which is divided into 256 channels, each having bandwidth of 4.312. So, the entire bandwidth is divided into 256 channels, out of which one is that channel 0 is dedicated for voice, channel 1 to 5 is not used, it has been left for future. Then there is a upstream channels, 24 upstream channels, one of which is control channel from 6 to 30, and downstream channels 31 to 254. So, you have got a larger number of downstream channels compared to upstream channels. You may be asking why. Suppose you are having internet service through a DSL line, then from the home to the internet service provider, the data rate is much lower compared to, because most of the time you are downloading something which has much higher bandwidth. So, you require much higher downstream bandwidth, that is why the number of channels allocated for downstream is much larger. So, 200 and as you can see 31 to 255. So, here the discrete multitone technique is explained. As you can see here, it uses voice channel, this is your channel 0, then channel 6 to channel 32. Here there are some serial to parallel converters. So, upstream bits are coming, and which is converted into 24 channels, and each of the channels is encoded by using QAM, 15 bit QAM, and each of them is connected to a FDM multiplexer, frequency division multiplexer. And similarly, the downstream signals, there are 31 to 255 channels, 31 to 255. These channels are again is here whatever is coming, the digital data is converted into that QAM, that is your quadrature amplitude modulation. Then you are doing parallel to serial conversion. Here there is a mistake, spelling mistake, parallel, and here you get the downstream bits. And this is where at the end of this frequency division multiplexer, where you have got 256 channels which are combined, each having a bandwidth of 4.312 kilohertz each, gives you a bandwidth of 1.104 megahertz. This can be this frequency division multiplex, these signals can be sent through the twisted pair of wire. from home to the telephone exchange using local loop. Here as you can see, channel 0 is reserved for voice in this discrete multitone technique, and channel 1 to 4 is not used, idle, as I explained earlier. Then upstream data and control uses 24 channels from 6 to 30, and for upstream data and control, one channel is used for control. That means 23 are available for data transmission. And as you can see, how you are getting 1.44 megabits per second, 24 into 4000 into 15. By using QAM, we are getting 15 bits. So it gives you 1.44 megabits per second for upstream. Upstream means from the home user to the internet service provider or the telephone exchange. And downstream data and control provides you 255 channels from 31 to 255 for downstream data and control. So you can see actual bandwidth is 244 into 224. Actually here it will be 224, not 255, 224 channels. So 224 into 4000 into 15, that gives you 13.4 megabits per second. So these are the maximum possible bandwidths available. For upstream 1.44 megabits per second, for downstream 13.4 megabits per second. But in practice, because of the line condition, the data rate is dynamically varied. In practice, you will get only 64 kilobits per second to 1 megabits per second for upstream and 500 kilobits per second to 8 megabits per second for downstream. So it is far lower than the 13.4 megabits per second, because usually the local loop quality is not very high. So unless it is very close and quality of cable is very high, you won't get very high bandwidth, but this itself is quite high compared to 4 kilobits per second. And the equipments used in ADSL is shown here. So this is this is the customer residence, that is home. The local loop is coming here. With the help of a filter, you are separating out the voice channel, and one is going to ADSL modem. ADSL modem is getting back the data from the here, as you know, you have got frequency division multiplexing is done, and that FDM, and it is performing the conversion, demodulation, giving you data of much higher rate, and which is going to your computer. Similarly, from the customer premise, it is going to the telephone exchange, and here there is a filter, it is going to the telephone network, and there is a DSL AM, that digital service line access multiplexer. So this access multiplexer actually not only does the modulation, that necessary multiplexing and other thing, it also does the framing, so which is needed for internet communication to the internet service provider. So this goes to the internet service provider. So using these two equipment, you can have the ADSL service. And there are other DSL technologies like symmetric digital subscriber line, SDSL. This divides the available bandwidth equally, because in this case it is not for home users. So bandwidth, there is no need to have separate bandwidth for upstream and downstream. So here the bandwidth is equally divided. Then you can have high data rate digital subscriber line, HDSL, which is an alternative to T1 line. As we know, the T1 line uses the AMI amplitude mark inversion encoding, and it is very susceptible to attenuation and noise, attenuation at high frequencies. As a result, you do not get more than 1 kilometer without using repeater. On the other hand, in HDSL, it uses 2B1Q encoding, and which is less susceptible to attenuation. It allows you 2 megabits per second over a distance of 3.6 kilometer compared to 1 kilometer without any repeater, and it uses 2 twisted pair wire for full duplex communication. it allows you to have full duplex communication. Finally, that very high bit rate digital subscriber line VDSL, it is similar to ADSL, but it can use coaxial, fiber optic or twisted pair wire for short distances, and using this DMT, that modulation technique that I have explained, it allows you 1.5 to 2.55 megabits per upstream and 50 to 55 megabits per second downstream. It will not be upstream, it will be downstream. So, these are the different variations of DSL technologies that I have discussed, and here are the review questions. Distinguish between analog switch service and analog lease line. Second question, if a single mode optical fiber can transmit at 10 gigabits per second, how many telephone channels can one cable carry? Question 3, how DSL provides broadband service over local loop? Fourth question is, why the actual data rates available through DSL line is substantially lower than maximum possible rates. These are the 4 questions which will be answered in the next lecture. And here are the answers to the questions of lecture number 11. First question was, in what situation multiplexing is used? Answer is, multiplexing is used in situations where the transmitting media is having higher bandwidth, but the signals have lower bandwidth. That means, from different channels the bandwidth is lesser. Hence, there is a possibility of sending a number of signals simultaneously. In this situation, multiplexing can be used. Multiplexing can be used to achieve the following goals. Number 1, to send a large number of signals simultaneously. 2, to reduce the cost of transmission. 3, to make effective use of the available bandwidth. So, these are the goals of multiplexing, as I explained in the last lecture. Second question was, distinguish between the 2 basic multiplexing techniques. Answer is, the 2 basic multiplexing techniques are frequency division multiplexing and time division multiplexing. FDM can be used to transmit a number of analog signals simultaneously in different frequency bands. TDM, also known as synchronous time division multiplexing, is used when with digital signals by sending signals from different sources in different time slots of a frame, as I have explained in the last lecture in details. Third question was, why guard bands are used in FDM? Answer is, in frequency division multiplexing, a number of signals are sent simultaneously on the same medium by allocating separate frequency band or channel to each signal. Guard bands are used to avoid interference between 2 successive channels. As I have seen, if you do not provide guard band, then there is a possibility that signals of 2 adjacent channels will overlap, leading to crosstalk. Finally, why sync pulse is required in TDM? In TDM, each frame time slots are pre-assigned and are fixed for each input sources. In order to identify the beginning of each frame, a sync pulse is added at the beginning of every frame. So, essentially the frames are to be beginning of each frame has to be identified. That is done with the help of the synchronization pulse provided in the beginning of the frame. The fifth question was, what limitation of TDM is overcome in ATM and how? In time division multiplexing, each frame consists of a set of time slots and each source is assigned 1 slot per frame. In a particular frame, if a source is not having data, then that time slot goes empty or it goes wasted. As a result, many of the time slots are wasted, as we have seen in details. This problem is overcome in ATM, which stands for asynchronous time division multiplexing or statistical time division multiplexing. And in ATM, the time slots are not pre-assigned to a particular data source. Rather, slots are dynamically allocated, as I have explained in the last lecture, to sources on demand. So, it is dynamically allocated on demand depending on the availability of data from different sources. That is how it makes better use of the bandwidth of the transmission media. Finally, this is the last question that was given. Design a time division multiplex system having output bandwidth of 128 kilobits per second to send data from 4 analog sources of 2 kilohertz bandwidth and 8 digital signals of 7200 bits per second. Here it is shown these 2 kilohertz analog signals which are coming from 4 channels are converted into digital form by using pulse code modulation. Each is converted to 64 kilobits. So, you see 2 kilohertz. So, you have to sample at 4 kilohertz, then by each PCM has 4 bit AD converter. So, you get 16 kilobits for each channel. Then you have got buffers of 2 bits here. Similarly, the 7200 bits per second, here as you can see, here we shall be sampling at the rate of 8 kilobits per second. So, you have to do pulse stuffing, as I explained in the last lecture. You have to add additional bits by pulse stuffing, and that is how you will convert these 7200 bits per signal to 8 kilobits per signal. So, these 8 kilobits per signals channels are each provided with 1 bit buffer, and here you have got the multiplexers which are generating 64 kilobits per second signals, and here you have got 8 bit buffer, and here also you have got 8 bit buffer. Then alternately you are taking 8 bit from there to get 128 kilobits per second composite signal. And here is the frame shown: channel 1 2 bit, channel 2 2 bit, channel 2 4 bit, channel 4 8 bit. So, here you get 8 bit from this source and another 1 bit from each 6, 7, 8, 9, 10, 11 and 12. That gives you the signals coming from channel 5 to channel 12, and this is the entire frame. Of course, here the synchronization bit is not shown, just the multiplexing part is shown in this particular diagram, and how you are getting 128 kilobits per second. So, with this we come to the end of lecture number 12. So, here we have discussed 2 very important applications of multiplexing. In the next lecture we shall discuss 3 important applications of multiplexing. Thank you.